Hello, can you hear me?
Yeah, I can hear you.
So for today's question, we're gonna do a graph question.
Here is a simple puzzle. Given a grid of size m by n, each cell will either have a circle or a triangle. A triangle represents land and a circle represents water. Your task is to find the total number of islands on the grid. Here is a simple example. An island is classified as any land that is surrounded by water. You may assume all four edges of the grid are all surrounded by water. Adjacent land horizontally or vertically are considered the same island. In this example, we have a total of 3 islands.
So you will be given a board size n by m.
Mhm.
So basically on the board there'll be like ones and zeros on it. We'll have a board something like this, and then we'll have ones and zeros. We want to look for a continuous block of ones. So you see there's one here, and then there's a one underneath, and then this one on the right. Together, this whole block right here forms an island. So let me just copy this and paste. Yeah, I'll just mark them as an X. So that's one
Mhm.
island. This will be considered another island. And you can just, yeah, assume the zeros are basically water. So basically what an island is basically anything that is a continuous block of ones, and then once it's separated by a zero, it's not considered an island. So the goal today is very simple. We just want to figure out how many islands there are in total on this board. Feel free to walk me through your steps, what you're thinking, and then later on we can jump into coding.
Okay, got it. Just so I just want to make sure I fully understand the prompt. So in this case, seems like we have multiple lists or arrays, and we only have inputs of either ones or zeros.
Yeah.
And in this case, this is treated as an island because from this position 1, we can either go to the right, we can go diagonally, and we can go to downwards as
Oh,
well.
sorry. We don't count diagonal, so we only count anything that's up, left, right, or down.
Oh, okay,
So
got
no
it, got it.
diagonals.
Yeah, okay, I see. So in this case, I guess if we took a look at this example, so this, oh, sorry, like the one here and here would be one island. This one would be an individual. Oh wait. Oh, I see. Okay. So in this case, this and this here would be one island. So that would be one because it can go down and then it can go to the right.
Yep.
This one will be one island as well because we can go down and down as well. And then we'd have one island here. So the output technically would be 3 islands, right?
Yeah, that's correct.
Okay, got it. That
Um,
makes sense.
Yeah, so while you here, let me just create a sample board for you, so you can have a test case.
Hmm. Okay, I see. Um, okay, so let me think of this. Just give me a minute just to kind of reorganize my thoughts and try to see if we can come up with an optimal solution for this.
yeah.
All right, let me start with kind of the brute force approach that I would follow for this. So in this case, just kind of like how I described it, and kind of the prompt as well. So given the position that we're in for the sample board, so in this case, if we're at here, then we can only go left, down, or right, and we'd essentially be doing that traversal, checking if at any direction, whether it's up, left, right, or down, to see if we have a 1 or not. So if we have a 1, so let's say if we started here, then we went down, if we have 1, then we would do the same kind of traversal approach where we would check again if we can go up, left, right, or down, and if there's a 1 in any direction that we follow through. And if we land here, then we can see that we don't have any 1s in the up, left, right, or down directions. But the problem with this approach is that if we follow this approach to the T, because in this case, we have a 1 to its previous direction, which was left in this case. So we'd also kind of have to consider a sort of data structure to ensure that we don't revisit any nodes that we have visited already. And that way we can essentially ensure that this one that we've visited is considered as one island. And that also goes to the same case as if we went with this approach where we continuously went down, and that would be considered as one island. And we don't have to revisit the previous nodes that we have already visited. And also in the case for if we encounter any zeros, then we'll have to skip that process. We only want to consider any scenarios where we can move in any directions that are listed, and we do have ones in the direction that we've encountered. So kind of following, I guess, the approach that I just mentioned, I'm just going to write some comments just to make sure that I can track back. We can follow a depth first search approach where we're going deep first in order to traverse the board. And then we can compute the outputs, which will be the number of islands. Conversely, I think we can also use a breadth first search approach where we go level by level first. And the main reason why I say breadth first search and why it might be more ideal is because given the sample board that we have, and because a breadth first search goes level by level first, it might be more intuitive to use that approach, especially for calculating the number of islands instead of a depth first search approach. Because in that case, if we say we go depth first search, then we just go we go deep first. So in this case, we start at 1, when we start at 1 here, and then we go to the right in this case. But we wouldn't necessarily think of all the possible ones in each level that we're traversing. And also, I do think that using a breadth first search along with a queue as an additional data structure might be more intuitive and easy to read rather than a recursive depth first search approach. So I think, what do you think? Do you think either could work, or are you okay with me following kind of the breadth first search?
Yeah, like I think both of your suggestions are great. Just feel free to choose one of them.
Okay, I see. So in the breadth first search approach, we would have to use a queue as an additional data structure to keep track of the nodes that we are currently at. So in this case, I'm just going to nodes that we have visited and want to visit its neighbors as well. We'd also have to create an adjacency list. And the main reason why is because currently right now it's a little bit hard to, I guess, determine where we need to go based on the sample board or input that we have. So what we could do is could we create an adjacency list, or would the sample board be enough?
If you create an adjacency list, you're also storing something extra, right?
Do you think you need all that extra information?
Why do you need this adjacency list? Let's start with that.
Yeah, so the main reason why is because I think for this question is because I guess the main reason why I wanted to use an adjacency list is so in this case, given at index of 0 of the first array, we can go up, left, right, or down, and the adjacency list might help us determine, given the index position, which neighbors it has. But in this case, I think you are right. It does create additional memory, and we also might not need it because we already technically have all this information in the arrays that we are currently given, right? So in this case, we know that it can go left, right, or down. So let's say we are at the first array at index 0, and now we can go left, which will be first array of index 0 plus 1, and we can also go, left will be minus 1, in this case. So in this case, we wouldn't be able to go to the left, and we'd have to consider that in our logic as well. And if we say we can go right, then we go index plus 1. And then if we go down, then it'd be first array, or actually, sorry, it'd be the second array, but it'd be the same index. And then up in this case, we can't go up because we are restricted by the index and as well as the given array that we're at, but technically it would be given array minus 1 and then same index.
Okay.
Yeah. So in that case, yes, we wouldn't need the adjacency list because we can already predetermine all of this information, whether it can go left, right, down, or up, depending on which index we're on and which given array index we're on.
Right, but you still don't have a way to know like whether you visited a node before yet.
Yeah, so in this case, what we could do is we could store that information in a set.
Okay.
And how we could do that is we could store that information for the given, I guess, array index. Let me just write it down. And then the position index within the array. And we can store our information all in set. So if we ever encounter any elements with 1, and we want to determine if it can move left, right, down, or up, we would also check that the given position that we want to go to is not already included in the set. And if that is the case, then we can go to whichever direction where 1 is present.
Okay, that makes sense.
So in this case, we would have to use this additional memory for the set, but the advantage to this, I guess, is we could keep track of where we can move, and also we're not creating an additional adjacency list, so this would be the only additional memory along with the queue that we'd have to use to keep track of the current node that we're on.
Okay, yeah, that sounds good. Do you want to start coding?
Yeah, for sure. So I'm just going to create a function, and I'm going to just name it number of islands. And in this case, we're going to, let's say I'm just going to get a grid in this case. Let's see, as the, and then I'm going to, first of all, check if we don't have the grid, if it's not a valid input. Should I output?
Yeah, so if there's,
negative
you can just return 0 in the case where we have nothing.
Okay, sure, sounds good. So I'll just return 0 in this case, and then I'll initialize my queue, which will be that collection, and also I'm just going to initialize also my set as well. So I'm just going to call it as scene nodes, and I'm going to initialize as my set. And then what I'm going to do in this case is, because we need to iterate through the sample board, and also I want to make sure that we're starting at the first index, so I'm going to append grid of 0 and 0 in this case. And I'm also going to add this to my set as well, so that it's present in the set. So now what I need to do is I actually need to iterate through the sample board. So, okay, so let's do for, so it's an array of an array. I do it in one for loop. Actually, I might need to, yeah, I'll do for I in range, because I need to get the index of not only the array index, but also the position index as well. Going to grid, and then I'm also looking for j in range of length of grid of, so in this case, it's 0, yeah. And then what I first need to do is I actually need to check if grid of I and j, oh wait, this would be, I need to also create a result variable.
Okay.
And in this case, because I have a queue, oh, actually, in a breadth search approach, it might be better to work from bottom up. So I'm going to essentially work from bottom up in this case. Then in this case, I guess we need to pop the element. And then, so we only want to keep track of, so let's say I pop this. This is what I had stored. In this case, I can only go here, and I can only go here. And actually, I'm starting from the bottom.
Sorry to interrupt. I just want to ask, like, what's your rationale for, like, why is it better for breadth first search to start from bottom up?
Actually,
Yeah,
no,
it's fine. I was just curious, like, what your thought process was for that. But I think, yeah, just keep going. I think what you're doing makes sense.
Okay, so now what we do is, okay, for j in range of my grid, okay. I also need to check that, so in this case, we start from, actually, sorry, I'm kind of confusing myself.
Yeah.
Because I appended the first element, so if I go through this approach, I actually need to append the last element of the array.
Yeah.
Sorry, of the array list. So in this case, we just length of grid, and then I'm going to initialize length of grid of 0, and minus 1, and then minus 1 as well. And in this case, I'm going to just approach so I don't have to recompute it every time. And also this is important because for any position, we can only go left, right, down, or up. But if, let's say, we're starting here, then we can't technically go down or to the right because it's at the last index.
Okay.
So now that we've popped this, what would I need to check first? I need to check if it can go left, right, down, or up. But actually, I should probably check if it's 1 or 0. Are these strings or integers values for this one?
Yeah, so we're just dealing with integers here. If
Okay.
you look on line 21, that will be like the sample board we'll be using.
Okay, got it. And in this case, if node is not equals to 1, then we continue. But also in this case, we'd wanna start from bottom up as well. Because so we do here.
Yeah, so what do you want to do when you see a 1?
So in this case, if we do see a 1, then we need to determine if we can go in the directions that are available to us.
Right. Yeah, that makes sense.
I guess let's do down first. If
so yeah, feel free to scroll up to line 35 to 39. I think you already wrote like the logic.
Yeah, so in this case, because this is the row, if I plus 1 is greater than row, Then in this case, we'd also want to continue. Yep. And then if same index, if, and then let's check for up. So if I
Give an array I minus 1 is less than 0,
then we also continue, and then we write if j plus 1 is greater than column, then we also want to continue, and then we go to the left. If j minus 1 is less than 0, then we continue as well. So we just went through all the cases where it's not possible to continue.
Okay.
And then if none of this is true, then we need to get to the first element where there's a 1. Okay. And also not in scene. Okay, so let's see. Let me just compute possible columns and rows. So how could we do this such that we can discover the right, left, and down elements? Oh, actually, I plus 1 is equals to 1. Oops, not this one. J. Actually, I'll just leave this for now, but I think what I'm doing below is basically going to be the same concept. Yeah. And then if you, oh, oops, this should not be this. This should be, since this is a set and we're keeping track of the indexes of the column, should be this.
So what is that?
What's this called?
Scene nodes. So this is the set.
What are you using to store this? Like,
oh, so I'm using to store the index of the row as well as the column.
Sorry, what data structure is this?
When you
This
store
is called a set.
Put a bracket here with a comma.
Oh,
what is that
sorry,
called?
it's called a tuple.
Yeah. Okay. Thanks.
Yeah.
That makes sense.
And I'm going to check if I plus 1 and j not in the same nodes. Then I'm going to append grid I plus 1 and j. And in this case, what do I need to do? So we also want to compute the total result, which is going to be total number of islands. And so in this case, if we do see one of these, so we've already encountered the case where we don't have, if we don't have a 0, then we just continue. But what we also need to keep track of is the result.
What did you say? Do you mind repeating?
Yeah, so in this case, I guess the part that I'm kind of stuck on is, so a result output is going to return the number of islands.
Right, yeah.
And the part I'm kind of stuck on is, in this case, sorry, we need to also add this. So if this is not the case, so we've encountered, we've already dealt through if the given node that we're on is not equals to 1. So in this case, it would equals to 1. And if we went down, then we'd append it to our queue. But I guess the part I'm kind of stuck on is, so in this case, in the given output, so let's say we were at here, and then we could go down and this was 1. This would be treated as one island.
Yeah.
And all of this would be treated as one island. But if I kept, let's say I kept adding the result of plus 1 for each traversal that we can do where we have 1, then our output would be wrong in this case because we keep appending to it.
Okay. How about we take a step back from code and okay, let's focus on this sample board here. Okay. let's run through one example together. Let's start. So you start at the bottom, right? So let's run through what your code should do. Run me through all the steps of your code.
Yeah. So in this case, what we'll do is we'll start here, and then we'll essentially check if the given number that we're currently on is either equals to 0 or 1. So if it's not, then we'll move to the next element within the same row. And then, so if it is a 1, what we'll do is we'll check each possible traversal that we can do. So we can either go up, left, right, or down. So in this case, we can't go right or down, so we can only go up. Up and left. But in this case, we only care about if a traversal will lead us to a 1 in this case. So in this case, we can go up, and essentially what we'll do is we'll do the same process.
Okay, so basically what you're telling me is, okay, so we start here, and basically what we do is, because this is a 1, we want to start our buffer search, right? So then basically what we do is we take this node and we add it to our queue. So yeah, it'll be better if we like try to draw it. So our queue will have sorry, what position is this? So this is 3 3 right? So now our queue will have 3 3, and then we'll have like a scene basically set that tracks what we've seen. So this is what we have. So basically now what we want to do is do buffer search. So we check left, so we don't care about that one because it's 0, and we check up. So then basically what we do is we want to, so basically we pop the queue, right? And then we put in basically 2 3. That is that element. And then now our scene will have 2 3, right? And then what do? We check left, and then we don't care, and we check right. So basically we pop this, and then we put whatever's above, which is 1 3, and then now we add this to our scene array, well, scene set. And then after that we go again, we check left and check right, check up, and then okay, then we just see 0 3, so then we pop, and then we put that in. And then finally now we have 0 3, and then now we check left, up, right, down. There's nothing else to do. And because this one's, we already seen it already, there's no point in putting into our queue. So now we empty it, and now that our queue is empty, we're done our buffer search. And then now what happens after we're done this buffer search?
I guess in this case, we would have to increment our results.
Yeah, so our result will now have 1, right?
1, right.
Okay, so yeah, that's basically what we do. And then after this step is done, because you do have this loop on line 66 to 68, you're basically going through the whole board. So next we go to the 0, and there's nothing to do because it's a 0. Then we go to the left again, nothing to do again. Now we see this 1, we add it to our queue, add it to scene, increment result,
got it.
and then hopefully this cleared things up. Just to give you a heads up, we have I think 20 minutes left for the question.
I see. No, that makes sense. I'm also curious, like for like the queue, I know you essentially because I think for mine what I was doing was I was actually appending the given value at the position that we're on, but in your example you were appending the tuple, which is the index of the row as well as the column. So I think in this way, would it still be the same approach, or would it matter?
What is your goal like with this? So I guess here in the queue on line 62, you're appending. Oh, so yeah, basically what you're doing is you're appending like 1 or 0, right? Depending on what's in that row column. But I think in order for us to do this problem, we probably need to know what the row and the column is, right? Because if you're passing just 1 or 0, that's not enough information for you to traverse the grid, right?
Got it. That makes sense. So in this case, it would be the same approach here. We just have this as well. and
Yeah.
we can. And what we can do is once we pop it, position, we'd have to get the row position as well, and then so in this case, this would not be the case, and we would also append grid I plus 1, oops, and j in this case. And also one thing that because we are only appending to the results after a queue is empty, we'd have to also add that logic in, but it wouldn't be in there. Actually, let me just try to just compute all of the possible scenarios first, and then we'll get
sure.
back to that. Oops. Oh, whoops, this wouldn't be I, it would actually be I plus 1.
Sorry, what's row position?
So
never
in this
mind. Sorry,
case,
I see.
yeah. And then we would end queue. -1 here. And then we would also determine if column plus 1 is less than column. Good. That will I. Then it would be similar in this case where you can only go +1, -1. This would be +1, -1, and this would be +1. Then the fact of that, we can just remove all of this because we're already dealing with that.
Okay.
And if that is not the case, then we'll just continue as well. And so the last part now that we want to check for is the result output, which will only append if our queue is empty. Okay, so we pop left, then we need a while loop in this case.
Yeah. So yeah, let's think about that. So why do we have a queue? Like, what's the purpose of this queue?
I guess it is technically duplicate information now that I'm taking a look, because in scene nodes we already have this information, and in our queue we're just appending the elements, but technically right now we have 2 for loops that are essentially iterating through both, the grid. So yeah, so now that I look at it, I'm not too sure.
Okay, well, so the reason why you created a queue is so that way you can do breadth first search, right? You need a way to basically traverse the grid to find all neighbors that are ones as well, right? So right now you're appending these nodes to your queue, but you're never popping stuff, right?
Yeah, right, because so in this case, we would need to essentially, if we have the queue, then we need to go back to this line 65, right, to make sure that we're popping the elements out of it, and we get to a position where we have an empty queue and we can append to our results.
Right.
Can we just break out of this for loop?
If you break, I guess,
No.
sure, if you want.
I don't know if that might be ideal though.
Okay, yeah, I think this is maybe a good spot for us to stop.
But yeah, let's go through your code together and like your approach and everything. So yeah, let's go to the start of the page. Just scroll up. Yeah, so we start around 10:43, and then we worked for I guess 40 minutes now ish. So yeah, so let's go through what we did. So yeah, I gave you a sample board. So I think like one thing you should focus on is if a sample input is given, before you do like jump into any code or anything, like try to work through the example, like see how you would solve it. So that's why I try to point you back into this and try like make you run through your algorithm with the example, so that way you could kind of see what you want to do. So next time, like I'd recommend you like doing that firsthand, so that way you're not writing code and then later on like getting confused.
Yeah.
So like it was nice that you told me there's depth first search and breadth first search. So I think one recommendation is like don't ask the interviewer which one should I do, right? I think like you should be more confident and make the decision on your own. Like okay, just say I'm gonna do DFS or I'm gonna do BFS. Because yeah, like you mentioned, like BFS is a bit cleaner in a way. So that's a good point. And then like I guess it's nice that you're like typing out why you're using this, and then you're writing these notes. But I think like one problem here is like okay, you did write down what the left right down like how to compute like the next node is, right? But then when you're down here in your code, like I think you're getting really confused here. And then I try to point you back, hey, you did write notes, right? Like at least try to use your notes. That will save you some time. And then so it's nice to use a set. Like that's a good data structure to use here. One thing I would note is when you mentioned that you didn't mention you were going to use a tuple, right? So that's why I tried to ask you, what are you using, right? So like when you're interviewing, it's nice to mention like the data structures you're using, so that way it doesn't sound like you don't know your stuff. So it's good. Just say, I'm going to create a set and it's going to use a tuple to keep track of the row and the column. I think that's good. So right here I got confused. I don't know why you wrote function, but yeah, we can get rid of that.
I think it was just a habit. Right.
Yeah. So we started the question at 10:55 and we started the interview around like 10:43. So that's good. Like you spent like a good 10 minutes like just trying to explain your solution or whatever. So that's good. That's really good. I really like it when people try to explain their stuff before they jump into code. Because a lot of people they're given a question and they right away start coding, right? As an interviewer, like it becomes very hard for me to follow because I don't know what you're thinking. I just see you typing, so it's not good. So thank you for that. So the next thing that I would say is to be honest, I got really lost in this code here. And I'm pretty sure you're getting lost too because you have like so many variables and these if statements are very long. So that's a big no-no for me because when I see people start writing like massive code and copying and pasting, like I get super lost and I can't follow along anymore. And then like even if I want to help you, like I can't because like I'm getting confused myself. And then I have a question here. Like, I'm not sure why you mentioned, oh, like when you're doing breadth first search, it's better to do bottom up. Like, do you mind explaining that a bit more to me?
Yeah, like I can't honestly. Most. Let me think. I'm honestly not sure. I think also that at that point I also kind of set myself up for even more confusion and more failure by changing kind of my approach. And yeah, I don't think it was right for me to change it without fully understanding why I need to change it.
Okay, yeah, that's fine. I just wanted to know because like I don't know I usually just do breadth first search from the top. Like I don't never did it in the bottom. So maybe I just want to know if there's like some secret there. But anyways, yeah, let's work together to clean this code up, right? So yeah, let's get rid of this just to make it more clean because now I'm seeing all these minus ones. I'm getting scared myself. So let's keep it really simple. Now it's just like okay, we're going through the I's and the J's, okay? And then you see here, you're popping right here. Like I think maybe this pop should go over here somewhere. So let's move that out. Let's get rid of that, and let's put this here. So I don't know. What I generally like to do is, so right here, your code is getting really complicated. Like what you could do is you could just write a simple function, right? So let's write a function and just call it, is valid, right? Usually when you're dealing with grids or yeah, basically a board kind of question, like just give yourself just write yourself a function, that just checks the boundaries, right? If row is greater than equal 0 and oops, and row is less than, like, I don't know, let's give it max row and max column. So while row is less than max row, and then you also want the column to be greater than equal 0 and column less than max column. So basically, yeah, you don't even need the if here. You could just return this, and this will just tell you, okay, can I move to this position, right?
Right.
So now you can basically just get rid of yeah, now you can get rid of everything here. So actually for this queue, you can just do while queue, right? You don't even need this. Then basically all you want to do is queue.pop. Node is queue.pop left, and then here when you do see so here you'll see you can check if node does not equal 1, then here you can continue. And then basically now you can do your queue.append whatever the position thing, ij, right? So now you have your position. Now you're saying, while there's something there, what you want to do is you want to actually I'm not sure if you even need that. I think you just pop it, and then all you just do all you really care is the top, left, and right. So for top, it's basically you just check if I think there's some people like to do this thing where they declare like all the possible paths. So they kind of just create a variable called possible paths, and then all they do is in here they just have a tuple where you can have 0, 1. Let's see, wait, to go up you need to add, no, you subtract 1, and then to go down you want to add 1, and then to go left you want to -1, and then to go right you want to add 1. So something like this. Like some people do this just for keep their code clean. So now all you have to do.
I think I could have added this maybe in the comments, because I think like from line 41 to 43.
Yeah.
I described it, but it wasn't great words. I think the tuple and the array definitely helps to visualize a little bit better.
Yeah. So now with these possible paths, you can just for a path in possible paths, all you just do is take your tuple. So here you can say I don't know, let's just call it value equals can you add tuples together? I don't remember, but whatever. let's say, yeah, new path equals, like, you could just do, sorry, so, yeah, so here we just call this a node, and then we can just call, yeah, so we'll just call this new node, and then we can just do node, yeah, 0 plus path 0, and then node 1 plus path 1. And then basically now we have a new node, and all we just have to do is if
We need to
is
check if it's
valid,
right? Yeah.
yeah, so if is valid, then you just want to pass it the new node 0, and I think we have row defined here, and then new node 1, and then we put column. So now we just check, okay, if it's a valid one, then now we want to append to our queue, right? And then, oh yeah, so basically if we do see a 1, we could just, add 1 directly, right? Plus equal 1. So queue dot, okay, so if it doesn't equal 1, then we continue, and we also want to check if node is it not in scene nodes, then, oh, actually, yeah, we could just say if it's in there, then we can continue, because we don't want to check it again. And then here we check if it is valid, and we can also check if it is in, and this is not in scene nodes. Let's call it new node, not in scene node. Yeah, so here we're checking, okay, if it's valid and it's not in our nodes, then we append it. And then finally, yeah, this will keep doing its thing. It'll keep popping until it can't pop anymore. And then, yeah, that's basically it, I think. Let's get rid of this.
And then we just return our result at the end.
Yeah, exactly. Oh, so one thing is, I don't think you should put this C node here. And maybe we could get rid of this as well, because we don't really need to do that. And then here we can just return result. Let me see if this compiles. Okay, so that looks good. So
I think on line 71 it should be grid of I and J, right? Instead of node.
Oh, right, sorry.
Yeah.
Grid I, J.
And then 74 as well.
And then I, J. If this is in there, and then Q append. Yeah, I think that looks good.
Then, oh, I think on line, do we need to, I guess we need to append after 76 to the scene nodes, right?
Right, yeah. Yeah, so C nodes dot, is it append?
It's add.
Oh, add?
Yeah, for sets.
IJ.
And then on line, I think after 86, right? Yeah. After we append to our queue, we should also add it to our C nodes, right?
No, that doesn't matter because
oh wait, you're adding it on line
here 7. We add it. Yeah, I think that should be good. Hold on, let me just think. Yeah, that should be good. Cool.
Okay.
Yeah, so let me see if we can run. I don't know why it's not letting us run. Let me copy this. Call the function with sample board. Okay, name the queue. Okay, so we didn't import. I don't know if this site supports importing, but another way you could represent a queue is you could just use a simple list. And then here where you do pop left. Yeah, so inside pop left.
Pop. Right.
Yeah, you can just say pop and then 0.
Got it.
So let's run this. So column line 85. Column. Okay, now let's run. Oh shoot, I think we're in some infinite loop. Okay, I crashed. Let me refresh my page.
I see.
Okay.
So yeah, it is definitely a lot cleaner than what I had before.
Yeah.
Like the possible paths array, or sorry, the tuple of list definitely eliminates all of the logic and simplifies it a lot more
Yeah.
than I had.
Hold on, let me see. Why is it not? Oh, right. So technically, this queue, I don't think we need to declare up there. I think every time, whenever we see something new here, we could just start a queue. Because the queue is only used at each level, right? That's the only time when we want to do stuff. So we have queue,
Oh, I see.
and then here we'll put the ij in there. And we do that, and then while queue will pop, and then we get a node, and then we say for path and possible paths, new node equals node this plus the path, and then yeah, I think that should fix it. Let's run it again. Okay, never mind. We're crashing again.
Oh no.
Okay.
QI grid.
Sorry, there's like a bug. Okay, let me close my browser.
While queue.
Okay, let's comment out this queue for now. Let's just see if the code works at least. Okay, let me just print here. Let's run our code. Okay, so we got 8. That's fine. It counted each one, so that's fine. Okay, so our problem is somewhere in this while loop. So basically, while there's a queue, I will pop, and then I'll go through each path, and I'll say if for path in possible paths, my new node will equal node 0 plus path 0 and node 1 plus path 1. Okay, and then I check, okay, if it is valid, that means the new node 0 and the row, and so row has to be greater than or equal to 0, and row has to be less than max row, and column greater than 0, and column next than max column. And then we also check if the new node is not in the scene nodes, then we append it into our queue. Oh, okay, sorry. I guess we do need to add it to our scene. So
would it be new node in this case?
Yeah. So this should be new node 0. Oh wait, is new node is the tuple.
It's a tuple, yeah. I think it would just be new node.
Yeah, so I think that should fix our problem. So let's run our code, and here we got 6, so that's still not right. It needs to be 3. Okay, sorry. Let's print out the paths together. Actually, no. Let's print out the. Okay, let's add some prints to debug our code. So let's print out what node we're on. So let's print node ij, and then here let's print out what our new node is. Actually, let's put it inside here. Print new node, and let's print the new node, and maybe here for the node we can print let's just print while loop, and let's print the node as well. Okay, hopefully this will help us debug. Okay, so first we have 0 0, and our while loop has 0 0. So we found a new node at 1 0, so that's the one below it. And then we found another node at 0 1. Oh shit. My bad. So we also need to check. So yeah, we check if it's valid. But we didn't check if that node is actually a 1, right?
Oh yeah. That is correct.
So let's also check here, and
I guess grid of the positions.
Called a grid, right? Yeah. Okay. Grid new node 0 and new node 1 does not equal 1. Sorry, equal 1. Okay, let's run our code. List in must be integers, not tuples. Line 87. Sorry. Yeah, bad syntax. Yeah, and then we need that. Okay, that should fix it. And now we still get 6. Okay, we have some bug going on.
0, 1, 0.
What's that?
Let's see. Max row.
Okay, wait. Okay, let's just see what's happening. Okay, so we have no 0, 0, then while 0, 0. Okay, new no, we go to the bottom. Then we have 1, 0 now. And then we have a new node at 1, 1. And then while 1, 1, now we're done. So now we find the next one at 0, 3.
3.
So at 0, 3, we have this guy here. Then we go down. And then we go down again. 2, 3. And then 1, 2. And then
I think it might be. Wait. Are we appending every time we see a 1 on line 76?
Yeah, I think that should be fine because here we check if it's in our C nodes, then we continue. So we just skip it.
Oh, okay.
Wait, I think I found a bug here. So here we did the while loop up to 2, 3. 0, 1, 2, and then we didn't go one more down. There's one more.
2, 3.
So
it might be because of on line 61 and 62, the row and column is only length of grid -1, and column is length of grid -1. So we might need to do the equality sign, or subtract, the
okay, now we get 3. Oh, okay. Yeah. So that's important there. That bug got me good. But yeah, anyways, so yeah, when you're trying to debug code, like try to put print statements, try to like walk through your code and understand what's going on. So yeah, that was a good catch on you with the -1. I didn't even notice that. So I guess what we could do is so here we should just put row and column too, so all our code lines up. And yeah, I think that's pretty much it for this question. Does that
I have a quick
make
question?
sense?
Yeah, no, for sure. It's been a while since I've interviewed. Are we allowed to use like print statements to debug our code during the interviews?
Yeah. Why do you think you're not allowed?
No, I'm just wondering because like sometimes, because like for instance, I don't know, like Google, they've changed it, but they used to use Google Docs, right? And stuff like that. So
Yeah,
it might be a little bit.
So for those interviews, I guess like can't really debug your code, so you gotta walk through your code line by line and understand what's going on. But I guess that's what the interviewer is there for. Like they're reading your code, trying to understand. So if you're writing like really like hard to understand code, it's hard for them to jump in.
Right.
So in this case, like I guess we're lucky here because we do have an interpreter that we can run. So here we're able to run and add some print statements to see what we're missing. So yeah, we're able to catch. Okay, we didn't check for the 1, and we didn't, and we were missing like the row and the columns. So yeah, it's nice, like right, like here, like you did write down the steps you need to do. So if you do write stuff down, make sure you do check off the list. Double check your work.
Got it.
Yeah.
Makes sense. Yeah. Okay. Sounds good.